Okay, hello and welcome to this video on doing some calculations related to density. On the topic of density, this doggy over here is saying, well, the density of planet Saturn is less than that of water. So if you put it in a big enough bathtub, Saturn would float. But it would leave a ring. Get it? Because Saturn's got rings. Oh, these dogs, they are hilarious. Lol, I say. Lol indeed. Okay, let's get to what we're talking about today. So, after this lesson, you should be able to calculate density in either unit grams per milliliter for liquids or grams per cubic centimeter for solids, given mass and volume. Also, calculate mass given density and volume, and calculate volume given density and mass. Let's see how to do these things. First up, we need to know this formula. This is important. Let's take notes specifically on this formula right here. Right? So density, and units are either grams per cubic centimeter or grams per milliliter, is mass divided by volume. And so notice that we have units for mass being grams, units for volume being either milliliters or cubic centimeters. If we do the same thing with the numbers that we do with the units, we end up with these units, right? Grams divided by milliliters here, or grams divided by centimeters. So that's how the units work. So to find density, you just divide mass by volume. Talking about the volume first, when we are measuring smaller objects, we usually describe them either in milliliters, little m, big L for liquids, or cubic centimeters, which is centimeters and superscript of 3 if it's a solid. Those two, note, are the same thing. I will emphasize that again later on. Those are the same measurements. We just have one way for doing it for liquids, one way for doing it for solids. Okay. Moving along. How do we figure out the volume of an object? Well, there's two ways. The first way is pretty simple. Measure its dimensions and use a formula that calculates the volume of a solid. So, for example, if you have a box, the volume is length times width times height. And I happen to have this cube of aluminum right here. It is an actual cube of aluminum. And I simply stuck a ruler on it and measured that the side of it was 2.5 centimeters. So 2.5 centimeters there. And so then the volume is 2.5 centimeters times 2.5 centimeters times 2.5 centimeters, or 2.5 centimeters cubed, because it's a cube, so each side is the same. So then the volume ends up being, and sorry if this is getting cut off here, but the volume is, after you round it, 15.6 cubic centimeters. Right? So that's what it says right under there. Sorry about the thing in the way. Okay. And what if you have something that you can't readily calculate by measuring, right? Let's say you have a rock. It's got all kinds of angles. Or, in the case of what I have here, a bean. Let's say you're trying to measure the volume of a bean. Well, to do so, there's this handy little method called displacement. So displacement is simply the amount of water or other liquid pushed out of the way by an object. So we can measure that easily using a graduated cylinder. You may have seen these things in the past. These graduated cylinders are just skinny, tall things with volume markings on them at various points, and you read them. You probably even know. You read the bottom of the curve here because the water tends to stick to the sides of the glass. And so what I did was I just put some water in, and I measured that water was 3.8 milliliters. Then I put the bean in, so I put the bean into the actual graduated cylinder, and I noticed, and then I read the water again and found that it was 4.1 milliliters. 4.1 milliliters. So given that, what's the volume of the bean? Well, I can calculate that pretty easily by subtracting, not the volume of the bean, silly me, the volume of the water. Right? So the volume of the bean is the volume of the water and the bean minus the volume of the water. So this one on the left, this is the water only. This one on the right, this one is volume water and bean. So that's 4.1 when they're together and 3.8 when it's just the water. So by subtracting, we'll end up with 0.3 milliliters, and of course it's a solid, so we just say 0.3 centimeters, right? 0.3 centimeters is the volume of the bean. How do we get mass? That's the other thing that we need for our density formula. Remember, density is mass divided by volume. So we need mass as well. To get the mass, we can simply stick our bean on a scale and see what it says. So this is 0.5. And notice, important for when you're back in the classroom, little tiny g here, because this is set for grams, not ounces or anything else. 0.5 grams. So that's pretty easy, right? We just measure the mass in grams. And now we got to put it together, right? So let's use the density formula to calculate the density of the bean. So again, it's mass divided by volume. So the mass of the bean was 0.5 grams, and the volume of the bean was 0.3 cubic centimeters. So the density, B, is 0.5 grams divided by 0.3 cubic centimeters. And that works out to, you're going to see this on your calculator, scribble. 1 point and then a lot of sixes, right? And it's possible that your calculator may round the last 6 to a 7, right? But so we only have one number after the decimal place, so we're just going to go with 1.7 grams per cubic centimeter. Right? That is the density of our friend the bean, right? So grams divided by cubic centimeters gives us grams per cubic centimeter. All right. Let's try something where we calculate something besides density, because we can use it to calculate mass or volume. So here's a problem that's actually going to require a few steps. So let's think about it. The density of water at room temperature is approximately 1.0 grams per milliliter. The density of ice is approximately 0.9 grams per cubic centimeter. How much will the volume of a 10 cubic centimeter ice shrink after it melts? Interesting. It's going to take a couple steps, but first let's think about what exactly are we trying to figure out here. So what do we want to get as our final answer? We want to get a volume of shrink, right? Essentially, how much does the ice cube shrink after it melts? And so that volume is going to be how much volume we had of ice minus how much volume we had of water. And we actually already know that the volume of the ice is 10 cubic centimeters. So we need to figure out what this volume of water is to do the subtraction, which will get us the answer that we're looking for. So how do we figure out the volume of the water? All right, let's give ourselves some more room to work here. So we know density of ice. Let me do this in blue. Blue, ice is blue, right? So in blue, I'll say that the for the ice, our density is equal to mass divided by volume. And our density was given to us as 0.9 grams per cubic centimeter. And our mass was not given to us, although we know that the mass should be the same due to conservation of mass. And the volume was given to us as 10 cubic centimeters. So we need to solve for the mass here. So let's do so in a different color because that's fun. And pick some yellow. And so to do that, we're just going to multiply both sides by 10. Multiply this by 10. And so that should give us, feel like you're watching Khan Academy yet? So that should give us mass equals 10 times 0.9, which is 9 grams, right? We have 9 grams of ice. Now let's talk about the water. So the liquid water, the liquid water has a density. So again, I'm just writing out the formula. Density is mass divided by volume. And the density is 1.0 grams per milliliter. And that's equal to the mass, which stays the same, so it's 9 grams, divided by the volume of the water. Now we gotta solve for the volume, so let's multiply both sides by V. V for volume, V for volume. And so what does that leave us with? It leaves us with, back to my other color. That leaves us with 1.0 V equals 9 grams. Now we need to divide both sides by 1. And so what that should give us is V equals 9 cubic centimeters. Oops. So now we know, I'll change colors again so we can kind of show what we're doing here. Think a little back to the original. V ice minus V water. And so that is 10 minus 9 equals 1. And cubic centimeters, or you could report it as, you know what, this is liquid water, so let's report it as milliliters. Milliliters. Sorry about the terrible handwriting, but I'm having some lag in my pen setup here. But that is our final answer right there. 1 milliliter, that is the volume of shrink, essentially. That is the amount of volume change between the ice and the water. So that's a more complicated problem, but still just the same general principles. So hopefully that was enough to get you started, and we're going to practice some problems on how to calculate density after this. Thanks for watching.